Hello and welcome. This is Hurley, Chapter 6 in our logic book, Propositional Logic. We're going to look at symbols and translation. Today is 7 November 2017, and we are coming to you live from Orland Park, Chicago. All right. So I hope you guys read the chapter. I think he's pretty thorough. Make sure you looked at the mind tap and all the extra things, videos, whatnot. Try those exercises. Do the Applia practice exercises, and then ace the 3 chances you have at the Applia 4 credit exercises. The goal of this chapter, form recognition is facilitated through the introduction of special symbols called operators or connectives. We're going to get clear on these connectives, how to use them, what a well-formed formula is, how not to use them, that type of thing. So when arguments are expressed in terms of these symbols, determining validity often becomes a matter of mere visual inspection. Now, if you're ever lost and you think, what am I doing this for? This is just math. Then email me, let me know, since we're going to spend some time translating real-life statements in this chapter, but we could have done more of that in chapter 5. But why is logic important? We use logic all day long. We need to know what a good argument is, what a bad argument is, and so on. All right. So yeah, chapters 4, 5, and 6, we were talking about terms, but now in propositional logic, we want to deal with whole statements or propositions. Now, technically, propositions, well, if we do the metaphysics of it, they're the content of our minds, and we translate propositions into language. All right, statements are represented by letters, and these letters are then combined by means of the operators to form more complex symbolic representations. So we're going to be working with all these things in chapter 7. So quickly, simple versus compound statements. So we have to distinguish these two things. A simple statement is just one that does not contain any other element as a component. Example, fast foods tend to be unhealthy. James Joyce wrote Ulysses, parakeets are colorful birds. The bluefin tuna is threatened with extinction. These are all simple statements. All right. So we'll take any convenient uppercase letter, maybe select it to represent each statement. Also in this session, we're going to be I'm going to mention Polish notation, which is a different kind of notation. So if you are visually impaired, and are using Polish notation in this logic class, you're going to use those symbols. So actually, there will be some letters we'll avoid a Polish notation just to prevent confusion. And so that would confuse you actually if you use a B. All right. Simple statement example again. James Joyce wrote Ulysses. Now, compound statements, these will contain at least one simple statement. It is not the case that Al-Qaeda is a humanitarian organization. We can translate that as it is not the case that A, and we can translate it as not A. So the tilde you see there means is a negation or not. It is not the case technically. So let's look at some other compound statements. It is not the case that Al-Qaeda is a humanitarian organization. Diane Reeves sings jazz, and Christina Aguilera sings pop. Either people get serious about conservation or energy prices will skyrocket. If nations spurn international law, then future wars are guaranteed. The Broncos will win if and only if they run the ball. All right, we need a real football team there, not my nephew's favorite, the Broncos. Okay, so now let's look at how we translate these into below. First one, it is not the case that Al-Qaeda is a humanitarian organization. Okay, let me see, do we use symbols soon? Yeah, eventually. Well, we can do this now. Yeah, we can wait. All right. It is not the case that Al-Qaeda is a humanitarian organization. It is not the case that A, or we can rewrite it as tilde A, not A. Diane Reeves sings jazz and Christina Aguilera sings pop. So we have D, Diane Reeves sings jazz, and C, Christina Aguilera sings pop. Either people get serious about conservation or energy prices will skyrocket. So either people get serious or energy prices will skyrocket. Then, if nations spurn international law, the future wars are guaranteed. If N, nations spurn international law, then future wars are guaranteed. I'm going to change this because this won't work at Polish notation. Use last names. How about the Cincinnati Bank? No. How about all right. So do we already do that? The Bengals will win if and only if they run the ball. Okay. So this is tricky. Remember in the first statement, note that the statement is a compound even though it contains only a single component. So this is the negation, the tilde. It is not the case that Al-Qaeda is a humanitarian organization. All right, now we're going to go through all these different deals here. So you'll get to know these very well for the next few weeks. So the operator, the tilde is a negation. So no, it is not the case that. Remember, when we're translating this stuff, it's loose, and we often just translate aspects of ordinary language. But we do the best we can, because once we get it into the form where we can manipulate it, it's set. All right. Dot, conjunction, and also moreover. The wedge, disjunction, means or unless. Horseshoe, implication, if, then, only if. And the triple bar, equivalence, if and only if. All right. Let's go through these slowly. I should just mention that some logicians use the ampersand or an upside down wedge in place of the dot, and some use an arrow in place of the horseshoe or the double arrow in place of the triple bar. So Hurley doesn't use those, he uses these, so just be aware of when you're outside of this class, or if you're using other sources to help you, you'll just have to translate, instead of a horseshoe, the arrow, instead of 3 bars, double arrow, and an and or an upside down wedge in place of the dot. Sound good? All right. So ignore this if you're not doing Polish notation. But for Polish notation, we're going to use a capital letter for operator. N, C, D, I, and E. Negation for negation, C for conjunction, D for disjunction, I for implication, and E for equivalence. So we use capital letters and lowercase letters. All right. So saying that logical operators are used to translate these English expressions does not mean that they are identical. as I mentioned a second ago, any translation, certain distortion of meaning occurs. So, for example, English expressions as and or if or and only if can be vague and may vary with the context of what we are saying in speech. Whereas when we translate it into with the logical operators, we have it's clear, precise, and invariable. And that's how we can do these proofs. So that when we say that the logical operators may be used to translate expressions in ordinary language, would mean the operators capture a certain aspect of the English expressions. All right. So the precise character of this aspect is spelled out in 6.2, but we're going to skip that. If you want to take some time to look at 6.2, go ahead. All right, so let's look at how we translate these things. It is not the case that it is not the case that Al-Qaeda is a humanitarian organization. We write it tilde A, or not A. S and T, conjunction, we use the dot, S dot T. Either P or E, P wedge E. If R then T, conditional. If R then T. And then S, if and only if R. Got it? All right, so for Polish notation, ignore this class. The language we use Roman alphabet, uppercase letters. They're reserved for connectives, and lowercase letters for propositional or predicate letters, variables, and constants. So Braille distinguishes these by simply writing a single dot, the capital letter sign, in the cell immediately before the letter, turning it from lowercase into uppercase. So uppercase and lowercase versions of the same letter are represented in the same way, except the former uses 2 characters and the latter uses only 1. So this in turn means that the Braille capital letter sign function in the Polish notation is a way of indicating in what follows is an operator rather than a brand. As there are only finitely many letters in the Roman alphabet, we describe a small language with only a few atomic symbols. Some of you guys who are programmers, you may use Polish notation, so this might interest you. Everybody else, ignore this. Ignore everything that has to do with Polish notation. So there's no symbols because you can't read those in Braille. You reserve the lowercase letters P, Q, R, S, and T for propositional letters. And so yeah, for blind students, you never use N, C, D, I, or B since it will be confusing. Now for the uppercase letters, N will be negation, which is a tilde in our regular notation. C for conjunction, which we use a dot for the rest of us. D for disjunction, which we use a wedge, or I for implication, or the horseshoe, if then. A B is for biconditional, if and only if. So yeah, Polish notation is a prefix notation, which means we write CPQ for P and Q instead of the infix notation PCQ. All right, so Polish notation, you write complex formulas in the following way. Let F, G, and H be arbitrary formulas. Not F equals capital N, lowercase f. F and G equals capital C, lowercase fg. F or G equals capital D, lowercase fg. If F, then G equals capital I, lowercase f, lowercase g. F, if and only if G equals capital B, fg. All right. So, this is for everybody. It is not the case that A, not A, Polish notation, capital N, lowercase a. P and Q. P dot Q. Polish notation, capital C, PQ. Either P or E, P wedge E. Polish notation, capital D, lowercase p, lowercase e. If N, then F. N, horseshoe F. Polish notation, capital I, lowercase n, lowercase f. T, if and only if R. T, 3 bars R. Polish notation, capital B, lowercase t, lowercase r. Sound good? All right. So negation, let's just run over these again. so we get clear on them. So the statement not A is called a negation. It is not the case today. It is not the case that Al-Qaeda is a humanitarian organization. In Polish notation, capital N, lowercase a. It's a negation of proposition A. T and R is called a conjunctive statement, or a conjunction. In the conjunctive statement, the components T and R are called conjuncts. So T is a conjunct, dot R is the other conjunct. Polish notation, we write this capital T, C, lowercase t, lowercase r, the conjunction of T and R. Disjunction. So the wedge symbol is used to translate or unless. So a previous chapter I explained that unless is equivalent in meaning to if not. This equivalence holds in propositional logic as well, but in propositional logic it is usually simpler to equate unless with or. The examples they give are you won't graduate unless you pass freshman English is equivalent to either you pass freshman English or you won't graduate. And also to if you don't pass freshman English then you won't graduate. So the wedge symbol has the meaning of and or, that is or in the inclusive sense. Although or and unless are sometimes used in exclusive sense, the wedge is usually used to translate them as well. All right. P or Q, P wedge Q is called a disjunctive statement or disjunction. So in the disjunctive statement, the components P or Q are called disjuncts. So Polish notation, capital D, lowercase p, lowercase q, the disjunction of P and Q. All right, implication. These are conditional statements. If N, then F. We use the horseshoe. Expresses a relation of material implication. Its components are called antecedent and consequent. So these we don't want to mix these up, the antecedent and the consequent. In Polish notation, we say capital I, lowercase n, lowercase f. The implication of n and f, or I, f, n. If n, then f. If n, then f. All right, equivalence. P triple bar R is called a biconditional statement, or biconditional. It expresses a relation of material equivalence if and only if. Polish notation of the biconditional, capital B, PR. So it's P if and only if R. So the tilde symbol is used to translate any negated simple proposition. For example, Rolex does not make computers, tilde R, not R. It is not the case that Rolex makes computers, not R, tilde R. It is false that Rolex makes computers, not R. Polish notation, capital N, lowercase r. So as these examples show, the tilde is always placed in front of the proposition it negates. All the other operators are placed between two propositions. So also, unlike the other operators, the tilde can't be used to connect two propositions. You can't stick it in the middle, you can stick it on the outside. So yeah, so G tilde H is not a proper expression. The tilde is the only operator that can immediately follow another operator, though. So G and not H, I apologize for using the ampersand instead of a dot. Thus, it would be proper to write G and not H. In the Rolex example, the tilde is used to negate a simple proposition, but it can also be used to negate a compound proposition. For example, not parentheses G and R, G and F. In this case, the tilde negates the entire expression inside the parentheses. All right, sorry to confuse you with the ampersand, but yeah, dot, ampersand, you get it. All right, this concept of a main operator is very important. We got to get clear on this, and sometimes this is tough to figure out, but we'll have a lot of practice, and we can get this going. So the main operator is the operator that has as its scope everything else in the statement. So if there are no parentheses in the statement, the main operator will either be the only operator, or if there's more than one, it will be the operator that's not a tilde. If there are parentheses, brackets, or braces in the statement, excuse me. If there are parentheses, brackets, or braces in the statement, the main operator will be the operator that lies outside them. Excuse me. So if there's more than one such operator, the main operator will be the one that is not a tilde. All right, we just have to look at some examples. This is clear as mud. So, finding the main operators. Let's look at this statement. All right, what do we have here? We look, the main operator is the dot because the scope extends to everything else in the statement, whereas the scope of the wedge only extends to the J and K because they're in parentheses. You see that? In the statement not K and M, the main negation of the conjunction of K and M, the main operator is a tilde because the scope extends to everything else inside those parentheses. So in the statement, if K, then we have the negation of the conjunction of L and M. The main operator is the horseshoe because, once again, its scope extends to everything else in the statement. Take a look at that and see why the horseshoe, the conditional, is the main connective there. So excluding the tilde, the only operator it's outside, it is the only operator outside of the parentheses. All right, Polish notation, earmuffs if you don't care. Complex formulas. So for these complex formulas, ones that you merge connective, you have to leave a space whenever you introduce a connective other than negation after a propositional letter. All right, is that clear as mud? Well, let's look at it. So we'll look at two formulas, capital I, capital C, lowercase p, q, r, no spaces, and capital I, lowercase p, space, capital C, q, r. So the first formula says, if p and q are true, then r is true. The second formula says that if p is true, then the conjunction of q and r, that is true. Okay? This is tough to work out, but you'll eventually get it if you're using Polish notation. So look at that first one again. First formula says that if p and q are true, can you see this arrow? I don't know if you can. So yeah, if p and q are true, implication, this is a conditional. If p and q are true, if the conjunction of p and q are true, then r is true. All right? It's very, very different than saying if p is true, then the conjunction of q and r is true. So that's why we have to use space. All right, some other examples here. This is the conjunction of p and q or r. Capital C, lowercase p, space, capital D, lowercase q, lowercase r. So look at this mess here. Actually, I love Polish notation. It's fun. So if p, then if q, then q or not r. All right? So let's look at it. If p, we have if p, then we have if q, then the disjunction of q and not r. This is fun, but if you're doing Polish notation, I'm meeting with you, then we'll go over it until you get it. All right. So conjunction. This is the Hurley uses the dot. Forget the ampersand or upside down wedge. The dot symbol is used to translate such conjunctions as and, also, but, however, yet, still, moreover, although, and nevertheless. So Tiffany sells jewelry and Gucci sells cologne. T.G. Tiffany sells jewelry and Gucci sells cologne. Tiffany sells jewelry, but Gucci sells cologne. We'll translate that the same way. Tiffany sells jewelry, however, Gucci sells cologne, same thing. And Tiffany and Ben Bridge sell jewelry. We can't use this for simple notation. How about P? P for Ben Bridge. Good enough? All right, so you note that the last example is equivalent, meaning that Tiffany sells jewelry and Ben Bridge sells jewelry. So to translate such a statement as a conjunction of two simple statements, the original statement must be equivalent to a compound statement in English. For example, Mary and Louise are friends is not equivalent in meaning to Mary is a friend and Louise is a friend. So the statement can't be translated as M.L. Do you see that? All right, I like that example. Man, this is all out of focus. What's up? So, conjunction, C in Polish notation, but we have use a dot, normal notation. The wedge symbol is used to translate or unless. Oh, let's take a look at these. Let's look in the box here. This helps us look at the main operator now that we get all this complex mess. All right, do you see in the first one why the conjunction, the dot, is the main operator? Now look down to the second one. Do you see why that dot is the main operator? You have these two things with parentheses on either side, and so that dot applies to this whole mess here. And then the last one is getting kind of crazy, but you'll get to love these things when we get to chapter 7. You see those brackets on both sides. All that mess on that side, you have the dot, and all that mess on the other side. So you have that main operator. Does that make sense? All right. Let's look at disjunctions, which is or D in Polish notation. So the word either, which is often used to introduce disjunctive statements, has primarily a punctuational meaning, but the placement of this word often tells us where the parentheses and brackets must be introduced. The symbolic expression, if parentheses and brackets are not needed, either does not affect the translation. And a similar point applies to the word both, which is often used to introduce conjunctive statements. Let's take a look at some. All right, I like these. These are good examples here to try to. These are the two disjuncts, right? A, wedge, T. Polish notation, we write capital D, lowercase a, lowercase t. Aspen allowed snowboards or Telluride does not. So, yeah, A or T. Either Aspen allows snowboards or Telluride does. A or T. Aspen allows snowboards unless Telluride does. A or T. Unless Aspen allows snowboards, Telluride does. Okay? Also, from the English sense of these statements, it should be clear that A or T is logically equivalent to T or A. Also, what's the problem here? So, logically equivalent propositions necessarily have the same truth value. Polish notation, capital D, lowercase a, t. That's logically equivalent to capital D, lowercase t, lowercase a. All right, material implication. If P, then Q. Conjunction. You remember from chapter 1 what the antecedent is and the consequent. So the horseshoe symbol or arrow is used to translate if, then, only if, and similar expressions that indicate a conditional statement or an if-then statement. The expressions in case, provided that, given that, and on condition that are usually translated in the same way as if. But by customary usage, the horseshoe symbol is also used to translate implies. Although implies is used most properly to describe the relationship between the premises and the conclusion of an argument, we may accept this translation as alternating for implies. Polish notation, I means implication, capital I, lowercase p, q. If p, then q. All right, implication I, or horseshoe, or arrow. So the function of only if is, in a sense, just the reverse of if. For example, the statement, you will catch a fish only if your hook is baited, does not mean if your hook is baited, then you will catch a fish. If it meant this, then everyone with a baited hook would catch a fish. Rather, the statement means if your hook is not baited, then you will not catch a fish, which is logically equivalent to if you catch a fish, then your hook was baited. So read this over again. We're going to do some translations and exercises so you get this only if correct. This is a little difficult, but I like how Hurley uses an example where you actually, if you think about it, if it meant this, then you see everyone with a baited hook would catch a fish. All right. The if and only if translation rule. All right. To avoid mistakes in translating if and only if, remember this rule. The statement that follows if is always the antecedent, and the statement that follows only if is always the consequent. Thus, S only if H is translated if S, then H. Whereas S if H is translated H, horseshoe S. If H, then S. All right. So on the right, we have Polish notation. You guys can ignore that. And let's look at the rest of this stuff. If Purdue raises tuition, so does Xavier. If P, then X. Xavier raises tuition if Purdue does. If Purdue raises tuition, then Xavier raises tuition. Purdue raises tuition only if SXU does. St. Xavier University in Chicago. So, if Purdue raises tuition, then S raises condition. Mississippi State cuts enrollment provided that Ole Miss does. If O, then M. Mississippi State University cuts enrollment on condition that Xavier University in Cincinnati does. If X, then M. Mississippi State University cutting enrollment implies that Xavier does. If Mississippi State does, then Xavier does. All right. So you Polish notation people, you can see how you translate these things. Implication of P and X. Implication P and X. Implication of PS. Capital ION. So on. All right. So take a look at these, but you'll have enough practice examples where you get it. All right. Warning with conditionals, material implications. When you translate conditional statements, it's essential not to confuse the antecedent with the consequent. So just as 6 divided by 3 is not equal to 3 divided by 6, a statement if P then Q is not logically equivalent to if Q then P. Polish notation, capital I, lowercase p, q is not logically equivalent to capital I, lowercase qp. All right. So, happily, it will straighten you guys out, as we'll see when we get to our rules in Chapter 7. All right. Let's look at these examples. I like these in the box. So these are all conditionals because the main operator is a horseshoe. So you see that first one? If H, then the negation of J. Look at the second one. You have stuff in parentheses on either side, and that's how you know the horseshoe, the conditional. That this is a conditional here. The main operator is that horseshoe. Now look at the bottom one with the brackets. You got things in brackets on both sides of the horseshoe. So guess what? You know the horseshoe is the main operator. I should be using an arrow. Sound good? Wait a minute. Do I have these options? Check this out. Hey. I'm sorry. Just discovering this crap on Active Presenter. All right. Conditional material implication. That's our horseshoe. And we're going to revisit necessary and sufficient conditions. If you remember, we did this in Chapter 1, but let's review this again. So the horseshoe symbol is also used to translate statements phrased in terms of sufficient conditions and necessary conditions. Event A is said to be a sufficient condition for event B whenever the occurrence of A is all that is required for the occurrence of B to occur. On the other hand, event A is said to be a necessary condition for event B whenever B cannot occur without the occurrence of A. So some examples he gives. Having the flu is a sufficient condition for feeling miserable, whereas having air to breathe is a necessary condition for survival. Other things besides having the flu might cause a person to feel miserable, but that by itself is sufficient. Other things besides having air to breathe are required for survival, but without air, survival is impossible. In other words, air is necessary. Let me know if this is annoying. Email me. So, if sufficient condition, then necessary condition. And they'll use the device SUN. Oh, here it is here. So, for example, having the flu is sufficient condition for feeling miserable. If you have the flu, then that's sufficient to make you feel miserable. If you're surviving, then you are breathing. So, necessary condition for surviving. Sufficient condition for feeling miserable. So yeah. Do we just do this? Other things besides having the flu might cause a person to feel miserable, but that by itself is sufficient. Other things, and so on. I think I just did that. I did, sorry. So yeah, here's a little device here, mnemonic device, SUN. If you turn the U sideways, SUN. Sufficient, necessary. Sound good? All right, so here's a general rule. To translate statements involving sufficient and necessary conditions into symbolic form, place the statement that names a sufficient condition in the antecedent, this spot, and the statement that names the necessary condition on the consequent. Antecedent, consequent. There you have it. All right, so whatever is given as sufficient condition goes in place of the S. Whatever is given necessary condition goes in place of the N. Hilton's opening a new hotel is a sufficient condition for Marriott doing so. Hilton's opening a new hotel is a necessary condition for Marriott's doing so. All right. Material equivalence. The biconditional. So, normal notation, you'll use the triple bar symbol. I was taught with a double arrow. And Polish notation, you're going to use a B, capital B. This is how we translate the expressions if and only if and is a sufficient and necessary condition for. Okay? So, let's just take a look at some examples. The airport JFK tightens security if and only if O'Hare does here in Chicago. J, if and only if O. Polish notation, capital B, lowercase j, lowercase o. Excuse me. JFK's tightening security is a sufficient and necessary condition for O'Hare's doing so. Same thing. Capital B, lowercase j, lowercase o, or j, triple bar o. So the analysis of the first statement reveals that J, if and only if O, is logically equivalent to this mess over here. Okay, the conjunction of two conditionals. If J, then O, and if O, then J. So the statement JFK tightens security only if O'Hare does is translated if J, then O. And JFK tightens security if O'Hare does is translated if O, then J. If you combine them, you have two English statements. Shoot. Come on, man. Where's that stupid dot? There we go. So there, if you combine those, you got that. All right. So yeah, if you look at that, the similar analysis applies to this. Because the order of the two conjuncts can be reversed, J if and only if O is logically equivalent to O if and only if J. However, when translating such statements, we adopt the convention that, what is this? Oh no. Sorry. Got distracted here. Shiny object. However, when translating such statements, we adopt the convention that the letter representing the first English statement is written to the left of the triple bar and to the right of the triple bar. All right. Look at this box here. Remember, we're looking for the main operator. So what's the main operator here? There we see it. It's biconditional. So you got your parentheses over here on this side. Parentheses over here. So boom, we know that this is a main operator. Now we see this mess of a bracket over here. This mess of a bracket over here. Guess what connects them? This main operator right here, the biconditional. All right. So more about parentheses and brackets. So when you have more than two letters in a translated statement, you have to use parentheses, brackets, or braces to indicate the proper range of the operators, or else we're not going to know what's happening. So we'll look at this. This is ambiguous. What the heck? So what do we have to do? You have to introduce parentheses to either this or this. So we either get this. This is the main operator. Because here, there's no way to translate this. What's the main operator? It's a mess. Or this. Boom. What's the main operator here? All right. So when you have statements like this, you have to find some clue in the English statement that indicates the correct placement of the parentheses in the symbolic statement. Generally, these clues are given by commas and semicolons and by words such as either or both, or by the use of the single predicate in conjunction with two or more subjects. So let's look at some examples. Ooh, I like these. All right. So where do you, well, we should try these without cheating. But Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. All right. So you have this and right here. Boom. We have a conjunction. We have the dot. And then here's the main operator, or disjunct, wedge. See that? Prozac relieves depression and Allegra combats allergies. Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. Ah, this comma is helpful here, right? That's our main operator. So Prozac relieves depression, P. Then we have and Allegra combats allergies, or Zocor lowers cholesterol. All right. Either Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. So you look at this, boom, you have an either or. So this is going to be the main operator. Prozac relieves depression, Allegra combats allergies. Got that main operator here? Prozac relieves depression, and either Allegra combats allergies or Zocor lowers cholesterol. P and either A or Z. Okay? Prozac relieves depression, or both Allegra combats allergies and Zocor lowers cholesterol. Prozac relieves depression, boom, or both A and Z. Both A and Z. So main operator is right here. This is a disjunction. Sound good? All right. We're going to do this in Polish notation. Ignore this if you don't care about Polish notation. All right. So, with Polish notation, you always put the main operator on the far left, the outside. Okay? So, since this is the main operator, boom, this is a disjunct. So, boom, you put the capital D way out here. So you have capital D. It's disjunction of the conjunction of P, A, CPA, and Z. All right, see that? It's a disjunction of these two things, CPA and Z. Now let's look at the next one. Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. So, boom, we have a main operator, and so we know it's a conjunction. So we have the conjunction of P, and then we add a space, then we have a disjunction A-Z. So a conjunction of P and the disjunction of A and Z. I mean, A or Z. You see that? See how we translate this? If you just learn Polish notation, then just pay attention to this. Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. Capital C, lowercase p, space, capital D, lowercase a, lowercase z. So either Prozac relieves depression and Allegra combats allergies, or Zocor lowers cholesterol. Main operator here. So main operator on the far left, capital D, capital C, because you have the conjunction P and A, and Z. All right? Now, Prozac relieves depression, and either Allegra combats or allergies, or Zocor lowers cholesterol. That's how you write it. You know this main operator is a conjunction, so boom, conjunction right here. Conjunction P, space, capital D for disjunct of A and Z. CP space DAZ. And finally, Prozac relieves depression, or both Allegra combats allergies and Zocor lowers cholesterol. Main operator is a disjunction, so we have a capital D outside to the left. Capital D, lowercase p, space, conjunction of AZ. Capital D, lowercase p, space, capital C, lowercase a, lowercase z. That's fun. Once you learn this, I mean, you realize that it's manageable. All right, here's more examples. I'm not going to go over these. If you want to pause it and look at these, go ahead. Wait a minute, let me do this one. All right, this is a mess. If Merck changes its logo, then if Pfizer increases sales, then Lilly will reorganize. All right? So, you have this messy conditionals here, but we know what the main operator is going to be conditional. Now, where do we put it? So, if Merck changes its logo, then, if then, we have an if then statement. So, if Merck changes logo, then if Pfizer increases sales, then Lilly will reorganize. So this is all in a parentheses right here, this other conditional. Now how do we write this? Polish notation, capital I, M, space, capital I, P, L. The implication of M, space, if Merck changes logo, then if Pfizer increases sales, then Lilly will reorganize. Okay? This one's even messier in Polish notation. If Merck changing its logo implies that Pfizer increases sales, then Lilly will reorganize. So, main operator is this conditional, this horseshoe. So, all right, you always have the main operator on the outside, I. So, capital I, MPL. All right, so this, you know, is the main connective. Just give me the connective between this stuff and then that. All right. All right, let's take a look at this. What is this? I didn't finish this. All right, scratch that. Sorry, I gotta fix this. All right. Gosh, we're on slide 48 at 162. We're gonna have to do this in two parts. All right. Confusions. All right, these are good in the chapter. I could probably skip this. When a tilde appears, a symbolic expression by convention is considered to affect only the unit that immediately follows it. So, for example, not K or M, the tilde affects only the K. In the expression negation of the conjunction, of the disjunct of K and M, it affects the entire expression inside the parentheses. We got to get clear on this stuff eventually. All right. So the expression, it is not the case that K or M is ambiguous, because the range of the negating words is indefinite. So we have to eliminate ambiguity. So we adopt the convention that the negating words are considered to affect only the unit that follows them. So, it is not the case that K or M is translated not K or M. Alright. Here's a little box here. We don't want to confuse these statement forms. Alright. Alright, we have plenty of examples, I think, of these, so we won't get confused. All right. Much more do we have here? Okay, I think we're almost done. All right, De Morgan's rule. So, we're going to get to know this very well in Chapter 7. The statement, not both S and T, is translated just like this. Okay? Not both S and T. In Polish notation, we do this. Remember, we take the main operator, the negation, out here. It's the negation of the conjunction of S and T. Okay? So, by an important rule called De Morgan's rule, this statement is logically equivalent to negation of S or the negation of T. All right? Polish notation, we'll write it like this. This is the main operator, so we have D. Disjunction of the negation of S, negation of S, and the negation of T, negation of T. Capital D, capital N, lowercase s, capital N, lowercase t. For example, the statement, not both Stephen and Thomas were fired, is equivalent meaning to either Stephen was not fired or Thomas was not fired. Because the former statement is not equivalent in meaning to Stephen was not fired and Thomas was not fired, This is not equivalent to not S and not T. All right? Does that make sense? Not both. All right. So, in Polish notation, you can read this down here. All right, I'm losing steam. Let's keep going. We got a few more things here. All right, De Morgan's rule. So, yeah, I think we get this in 7.2. Maybe it's 7.3. I forget. But basically, this will be a handy rule to use. So yeah, the statement not either S or T is translated like this, which by De Morgan's rule is logically equivalent to this. All right. So you'll be using this a lot in a week or two. All right, this is important. Students mistake this. So you can't do the same like that. You're always switching here. All right. All right, here's some good examples. All right, Megan is not a winner, but Kathy is. It's not the case that Megan's a winner and Kathy. Not both Megan and Kathy are winners. So it's not both, not the case that this. All right? So negation is the main operator. Capital C, this is a conjunction, and then MK. All right, to go back to this one, Polish notation, you have capital C conjunction, this is the main operator, and you have the negation of M and K. Conjunction, so these are the two conjuncts. All right, either Megan or Kathy is not a winner, so not M or not Kathy. So what's the main operator? You have disjunction here, capital D. Capital D, so it's a disjunction between not M or not K. See that? Both Megan and Kathy are not winners. So, main operator conjunction. So you have not M, not K, conjunction of not M and not K. Not either Megan or Kathy is a winner. So not M or K. Boom. Parentheses, negation. This is our main operator, so we stick that on the outside, capital N, disjunction MK. Neither Megan nor Kathy is a winner. It is not the case that all this mess. Main operator, negation. Main operator. Disjunction, M or K. Disjunction, M or K. All right. Look at this box here. We'll have some confusing examples like this that we'll go over. Leibniz. Well, it's a video you can click. I don't know what the heck that is. Anyway, I want to mention Leibniz because
the 30 Years' War decimated the Holy Roman Empire.
we won't watch
What
it.
began as a local conflict soon progressed.
But look him up on the YouTube. I've got a slide. I had a slide. I forgot this slide was in there. Woofs. Well-formed formulas. So these are syntactically correct arrangement of symbols. We got to get clear on this or it's going to get messy. All right. So these are not well formed. All right. You can't have these right in a row. This, you got to have something here. Going to move this right there. And then this mess, you can't have that. We should have to look at some examples. All right. So statements include simple statements and compound statements. Remember, the negation of A is a compound statement, and statements cannot be combined without an operator occurring between them. So, like this, AB doesn't work. This doesn't work. This needs something right here. This needs something right here. This needs something right here. Here are some good ones. Boom. So you add this. Make it a conditional. Boom. Well, this junction, disjunction, this conjunction right here. All right, see that? Missing something here, missing something here, missing something here. All right, so yeah, tilde cannot immediately follow a statement. Can't do this mess right here. But it can immediately precede any statement. So like this. Or double negation. Except when it immediately follows a statement. So tilde cannot immediately precede any other operator. So yeah, you can't have this tilde in a conjunction there. Make sense? Or you can't have these together. You got to stick this on the outside, or stick it here. All right. So a dot, wedge, horseshoe, triple bar must go immediately between statements. You want to pause it and look at these examples. Parentheses, brackets, and braces must be inserted to prevent ambiguity. So yeah, this is just messy. You don't know what the heck to do with this stuff. You got to have some parentheses, brackets, and braces. All right. All right. Quick mention of Leibniz, 17th, 18th century. Don't skip this. Read it. Please someday look him up. When I teach philosophy of religion, we look at Leibniz's contingency argument for God's existence. So there are various arguments, various cosmological arguments for God's existence. You have the medieval Islamic argument, the Kalam cosmological argument, revitalized by William Lane Craig in the 1970s, which is a popular one, and it uses Big Bang theory to argue that, in the beginning of time, to argue that the cause of the universe must be outside of space and time, and this is the thing we call God. You have Aristotle's cosmological arguments, and then you have Leibniz's cosmological arguments. But my one buddy, we live together, and I'm not the best roommate in the world. But he told me years ago, you will never lead me to Jesus. Being the kind of guy you are, the roommate that you are, as messy as you are. But our friends Parker or Leibniz might lead me to Jesus someday. I thought that was very interesting. They threw Leibniz in there. Parker is our buddy who's just, he's the Anselmian man, greater than which cannot exist in a fallible human, because he's awesome. All right, reasonablefaith.org. Look up William Lane Craig's little deal here.
We live in an amazing universe.
But yeah, check that out. It's 5 minutes long. Also, if you do philosophy of mind, Leibniz is very important. The identity of indiscernibles, indiscernibility of identicals. When we're trying to figure out whether or not mental states, what are their relationships to brain states? Are they identical? And so on. All right. A Stanford Encyclopedia usually has great articles on these guys. Bertrand Russell's Chapter 3 on Leibniz, on YouTube, and so on. Check it out. All right. Come on, man. What's happening? All right. There I am, my Colorado shirt. This was in Houston, Texas last Christmas. Exercises. I think I've been talking long enough. Let's pause it. This is the end of part 1. And then part 2, we're going to do some exercises. Sound good? All right. So this is the end of part 1. Ciao. This is tougher. 7 November 2017. All right. Bye. Email if you have complaints about this. No. All right. See you guys. live from Chicago.